Welcome back to the deep dive. Okay, we've gathered up all those sources you sent over, and today we're setting sail into, well, the future of staying connected at sea. Our mission is a deep dive into Starlink Maritime, specifically how it's changing things for high-value yachting. Because let's face it, for years, getting online offshore meant insane bills and speeds that felt ancient.
Yeah, like dial-up days sometimes.
Exactly. And for a modern yacht needing good nav data, safety comms, plus, guests needing to work or stream, those old limits just didn't cut it anymore.
And that's precisely the gap Starlink was built to fill. It's SpaceX's low Earth orbit satellite system, LEO, we call it. The maritime version basically extends that fast connection way offshore, fundamentally changing how viable it is to be online once you're past cell tower range.
Okay, let's unpack that. We already have satellite internet at sea, right? Those big white domes you see everywhere. So what's the fundamental tech difference here? Why is Starlink such a big deal for yachts now?
It really boils down to altitude. Physics, basically. The older systems, what we generally call Viasat, use geostationary or GEO satellites. These guys are parked way, way out there, like 22,000 miles up.
22,000 miles. Wow.
Yeah, so your data has a massive round trip just to get there and back. That takes time. Starlink, on the other hand, uses this huge constellation of LEO satellites, thousands of them, orbiting just a few hundred miles up.
That's much closer.
Exactly. And that proximity is the whole technological edge.
So closer satellite. What does that actually mean for someone, say, in the pilot house trying to remote into their office server?
It means a massive improvement in what we call latency. That's the lag, right? The delay for your signal's round trip. With the old GEO Viasat, that huge distance means latency is often 600 milliseconds, maybe even more.
Half a second or more delay. Ouch.
Yeah, try having a natural conversation on a video call with that kind of delay. It's painful. Starlink, because it's so much closer, cuts that right down. We're usually talking well under 100 milliseconds, sometimes much lower, depending.
Okay, that's a genuine night and day difference. And that explains why things like Zoom calls, using remote desktops, accessing cloud apps, things vital for work from boat, suddenly become actually usable at sea. That just wasn't really the case before.
Absolutely. And it's not just low latency. The speeds are genuinely useful, too. Looking at the sources, yacht operators are seeing downloads often in the 40 to 150 megabits per second range, sometimes higher.
And uploads, because that's key for calls and sending files.
Uploads are typically decent, too, say 8 to 25 melodies plus. That's enough bandwidth for several people browsing, streaming HD, or even 4K all at once.
Let's quickly touch on the hardware because the Starlink antenna looks totally different from the old dome.
Right, no big spinning dish. It's a flat, rectangular thing called a phased array antenna. And that's crucial because those LEO satellites are zipping across the sky really fast. The phased array steers its beam electronically, no moving parts inside, to track those satellites instantly and then hand off the connection seamlessly as they go overhead.
So that complex tracking is built in, maintaining the link.
Exactly. It's key to keeping that connection stable and the latency low.
It's quite fascinating when you stack up speed, latency, and the cost per megabyte. Even with the higher maritime plan pricing, Starlink seems to come out ahead of the traditional options.
Yeah, generally speaking, you're getting a lot more performance for your data dollar.
But nothing's perfect, especially when you're operating in the middle of the ocean. The sources were pretty clear. You can't expect flawless 150 megs, 247 everywhere. Let's talk about those trade-offs. What makes the service dip?
Okay, the main challenges kind of fall into three buckets. First off, weather. Really heavy, localized rain, what we call rain fade or thick squalls, can definitely degrade the signal, sometimes interrupt it. It just has trouble punching through all that water.
Okay, weather. Makes sense. What's the second one?
Physical obstructions. This is a big one on a boat with masts, radars, antennas everywhere. The Starlink antenna needs a really wide, clear view of the sky. The sources suggest 140 degrees or more, ideally.
To see as many satellites as possible.
Right. If the yacht's own mast, or maybe a cliff face in a fjord, or even a tall building in port blocks that view, you're going to get dropouts.
And the third challenge?
Congestion. Simple as that. Starlink's capacity isn't infinite. In really busy maritime areas, think popular harbors, cruise ship routes speeds can noticeably slow down because lots of users are sharing the same satellite beams.
Right. More demand on the network.
Now, it's worth mentioning the maritime plan costs more than the residential one, partly because it gives you priority traffic over fixed users. That helps mitigate congestion somewhat, but doesn't eliminate it in really crowded spots.
Yeah, makes sense. Okay, so given those potential issues, why do some high-end commercial operators, according to what we read, still keep their old VSAT systems.
Ah, that brings us to the concept of the SLA, the Service Level Agreement. While Starlink generally offers much higher potential speeds, the legacy GEO VSA providers have mature global SLAs. Meaning a contract that guarantees a certain minimum level of bandwidth or a certain percentage of uptime, usually with financial penalties if they don't meet it.
Ah, so it's about guaranteed minimum.
Exactly. For some operations where 100% guaranteed mission-critical uptime is paramount, that contractual guarantee, even if the speed is slower, might still be preferred over Starlink's higher, but potentially more variable speeds.
Okay, so Starlink is faster, generally better, but not absolutely bulletproof 100% of the time. Which leads to the really practical question for yacht captains and managers. If you know Starlink can have these brief dips, rain fade, maybe a satellite handoff lag, congestion, how do the best operators guarantee that office-at-sea level of reliability their owners or charter guests demand?
And this right here is the core takeaway from all the source material we looked at. The answer, overwhelmingly, is the hybrid setup.
Hybrid, meaning not relying on just one connection.
Precisely. Relying solely on Starlink or any single connection at sea isn't really viable anymore for truly critical needs. You absolutely have to build in redundancy.
So what does that hybrid approach look like on the boat?
It typically means pairing Starlink Maritime with good quality, high-speed LTE or 5G cellular for when you're near shore or even in port. But the real magic happens in the network management system, that sophisticated router or firewall device on board.
The router. How so?
That device is configured for seamless failover. So let's say the Starlink signal dips for just a second. Maybe a heavy rain cell passes over or it's doing a tricky satellite handover. The managed router instantly, automatically reroutes all your active internet traffic over to the stable LTE connection.
Without dropping the connection.
Exactly. Your critical voice call, your remote desktop session, it all stays active. It effectively masks those brief Starlink dips that would otherwise kill a sensitive application. That's what delivers reliability for business use.
So it's not just about buying the Starlink dish. It's about architecting the entire onboard network properly, like you would in a smart office building. And that demands a really specific physical installation too, right? The source is really hammered at this point.
They absolutely did. Getting the installation right is critical for optimal performance. The antenna needs to be mounted high up, clear of any physical blockage, away from other domes, life raft pods, antennas.
And they specifically mention mounting it above any radar beams. Why is that so important?
Yeah, that's crucial. Radar emits powerful microwave energy. If the Starlink antenna is mounted at the same level or too close, that radar energy sweeping past could potentially interfere with or even damage the sensitive electronics inside the phased array.
So you could basically fry your Starlink terminal or just degrade its performance every time the radar spins.
Pretty much. So clear sky view, high up, and away from radar interference. And keep it clean, salt spray, bird droppings, that can affect performance too.
Okay, good physical setup. But then there's managing the data flow itself, right? This gets us into QoS.
Absolutely essential. Quality of service, or QoS, is non-negotiable in this kind of hybrid setup. Think of your yacht's internet pipe like a highway. If you just let everyone merge on at full speed whenever they want, you get traffic jams, gridlock.
Makes sense.
QoS is like having intelligent traffic lights and dedicated lanes. You program the network management system to prioritize traffic. Critical data navigation updates, VoIP calls for the captain. Maybe that remote desktop connection for the owner always gets priority, the fast lane.
And the less critical stuff.
Secondary traffic, like guests streaming movies, big background downloads, gets automatically throttled back or delayed slightly if the network gets busy with priority traffic. Without QoS, one person starting a massive game download could easily choke the connection and kill the captain's vital weather feed.
Right, you need to control the flow.
You have to.
That real-world feedback we saw really sums it up. People consistently say Starlink is night and day better than the old satellite systems, finally enabling those low-latency applications. But they also confirm the caveats. Rain can slow it down, speeds drop in crowded ports. It underlines that the solution isn't just Starlink.
No, it's Starlink integrated intelligently. It's Starlink plus smart network management.
So let's try and bring this to a final verdict based on everything we've reviewed. Starlink Maritime clearly represents a huge leap forward. It offers a really compelling mix of speed, low latency, and relative simplicity, making it arguably the new baseline standard for most private yachts.
I agree. And connecting that to the bigger picture,
Yeah.
its value is truly maximized when you stop viewing it as just a standalone dish and start seeing it as the primary high-performance pipe within a properly managed redundant network. That implementation, the smart router, the QoS settings, the seamless LTE 5G failover, that's what transforms Starlink from really good most of the time into consistently excellent for demanding real-world use at sea.
Well said. Which leads us to a final thought for you to consider. Given that modern work, safety, and even guest expectations increasingly demand continuous, reliable, high-speed connectivity offshore, will this engineered hybrid setup, the combination of Starlink, cellular backup, and sophisticated QoS, soon become the absolute non-negotiable standard for all high-value yacht operations, regardless of the added complexity and cost? Something to think about. Join us next time for another deep dive.